Hello again, everyone. Welcome to day 2 of our first unit in our flipped classroom, Algebra 2. Today we're going to cover solving linear equations, just a very brief review of things that you've done for a couple of years now. So this should be a really quick lesson, things you should have a lot of confidence with. So we're going to be looking at solving linear equations such as the one you see here, where we have 5x minus 9 equals negative 2x plus 19. And obviously, I'm not going to go through a lot of time instructing you how to do this, but I would like to take a minute and talk about the why of how we do these problems and why we do them the way we do. Because now you have a good understanding of how to solve this. I assume everyone here can solve this equation, but why we do what we do is something that is kind of better to revisit now that you've got a better understanding of how to solve. So most of you are pretty aware here. Our first step most of you would take would probably be to get all the x's over onto one side. That makes the equation easier to solve, makes it more comfortable with what we've seen in the past. But the big question is, why do we add the 2x, and why do we add the 2x where we do? This concept of an equation is something that hopefully now we can revisit and really understand a little bit more deeply here, where the whole key to that word equation is the base of equal. And when we're talking about algebra here, all the solving things we do, I often use the phrase, we're on a quest for equality. We're always looking to keep things equal. So that's where most of you can conceptualize, you add the 2x to get rid of the negative 2x because that would equal 0. But the reason why we add the 2x to the 5x is because we've added 2x to the right side of the equation, and you'll notice I've drawn a solid black line down the center of the equation, down the equal sign, just to kind of emphasize that balance idea of right side, left side. So we've added 2x to both sides, so therefore we are remaining equal. We have changed the problem, but everything still has the same value. It has remained equal. And we get to 7x minus 9 equals 19. And from here, most of you are very comfortable that we're going to add the 9, we're going to divide by 7 and get x equals 4. Now this is kind of the standard problem you've seen in previous classes where you lay out the work and you do the same thing to both sides. Now the large difference in what's expected of you between Algebra 2 and Algebra 1 is in Algebra 2 I'm going to be much less picky about the amount of work shown. This would be the ideal way to show the work. However, most of you can say I'm going to add 2x and skip the step where you write the plus 2x. Many of you could leave this step out and get directly to 7x minus 9 equals 19. And again, you would add the 9. You don't necessarily need to write each of those parts. You could just have each step written down. It is my advice that you show the steps simply to make life easier and to keep yourself more organized. But if you don't want to, I'm not going to be picky about that this year. So the one thing I do want to spend a little time with is solving an equation with fractions involved. And some of you have taken my Algebra 1 class and you've seen the way that we like to solve these problems. The 2/3 x plus 3/4 equals 1/6 problem you see here, this is one that intimidates a lot of people because we're uncomfortable with how we could go about solving this. We're uncomfortable with fractions and they kind of intimidate us. Well, one thing we can do in our solving step here is we can use a little trick of common denominators that allows us actually to not solve a fraction problem at all. And so when we look at the numbers 3, 4, and 6, hopefully all of you can see 12 is the common denominator we'd be working with. And the shortcut, the way I would like you to solve this that I'm going to show you now, is going to involve multiplying both sides of the equation by a common denominator. And again, what we talked about previously, we know as long as we do the same thing to both sides, we can do about anything we want in an algebra problem, as long as we're doing it to both sides. So if you look here, we've multiplied 12 by both sides of the equation. Now comes the part where I'm going to show you a little shortcut for multiplying a whole number by a fraction that's going to allow you to work with smaller numbers. When you do the 12 times 2/3, rather than putting 12 over 1 and multiplying that out, my advice would be to look at it as a multiplication and a division problem, where 12 times 2/3 is really 12 divided by 3 times 2. So if we take 12 divided by 3, we get 4. We multiply by 2, we get 8. So therefore, that 12 times 2/3, when we distribute the 12, it turns into 8x. Similarly, we can multiply the 12 by 3/4. By doing 12 divided by 4 is 3, times 3 is 9. And we also, because it's an algebra problem, if we did it to the left side, we have to do it to the right. 12 times 1/6 is 12 divided by 6, which is 2, times 1 is 2. So now, as we look at our new equation, at 8x plus 9 equals 2, that's an equation most of us are very comfortable with solving. We subtract our 9, giving us 8x equals negative 7, and we divide by 8, giving an answer of x equals negative 7/8. So therefore, we get to a fraction answer without having to do a whole lot of work with the fractions themselves. So one more example. You will come across one of these in your homework. Now, in order to use that fraction shortcut that I just showed you, we do have to do one thing first here. You cannot do the fraction shortcut over a parenthesis. So hopefully most of you look at this and say, well, we can distribute that 2/5 through the parenthesis. So we do 2/5 times 1/3 gives us 2/15. 2/5 times 1/2 is 1/5. And we still have the 5/6 on the right side. And as you can see, I already went ahead and found the common denominator of 30. And we're going to multiply both sides of the equation by 30. That again will eliminate the fractions from the problem. That gives us a nice easy equation by doing again 30 times 2/15. 30 divided by 15 is 2, times 2 is 4. 30 divided by 5 is 6, times 1 is 6. That's where the 4 and the 6 came from. And 30 divided by 6 is 5, times 5 is 25. So now we have a very simple equation we're all very comfortable with. So we start solving. 4x minus 6 equals 25. We add the 6 to give us 4x equals 31. And we divide by 4 to get an answer of 31/4. Again, an ugly problem with an ugly answer. However, the work ended up not being ugly because we were able to use a little shortcut to get ourselves into whole numbers. So our phrase for the day that we'll ask you about tomorrow is go Chatfield Gophers, and we have to make sure we say Chatfield Gophers because as you all found out yesterday, I'm a Hawkeye fan. We can't just say go Gophers. I don't want to confuse that with anybody from the University of Minnesota. So, all right, hopefully this is something clear. It should be something we have some good success with tomorrow.